So here we're going to look at Eulers Method. I'm going to talk you through exactly how we do this. Usually it's done when we're trying to find the value of a differential equation and we can't do the integration for that differential equation. Now in this particular instance I can do the integration, but what we're going to do is just do Eulers Method anyway for a simple one. So I make a little table, and in the table I have x, y and dy by dx. And I'm given my differential equation, dy by dx, there. Here is my initial values. So I'm starting off with x equals 0 and y equals 2. And here you can see we've got step size, and I'm going to do this one a half. So that's h, my step size is 0.5. And I'm trying to work out the approximation when I put 2 in. So how's this going to work? Well, if I'm going up to 2 in step sizes of a half, my x value is going to go up by 1/2, 1/2, 1/2, and 2. And this value in here, that's the value that I want. How do I do it? Well, I work out dy by dx using the 0 and the 2 at the start there. So dy by dx is e to the 0 plus 0. That's 1. No problem. Now I'll work out my next y value by taking the y from the previous value and adding on my previous dy by dx times by the h, the step size. So I take my 1 for dy by dx, I times it by a half, because h is a half, 0.5. I add it to my previous y answer to get 2.5. Now I use my two values, the 0.5 and the 2.5, to rework out dy by dx. In this simple case, there's no y's to plug in, just the x's. And this gives me 2.649. Now I repeat what I've just done to get my next y value. So I take 2.649 and times it by a half, and then I add on the 2.5 from here. So half of this value, add on this value here. And when I do all that, I get to 3.82. Okay, we go through the dy by dx process again. So we have e to the power of 1 plus 2, which gives me 4.718. I take my 4.718, I times it by a half, because that's h. I add on 3.82, and I will get, if I can just get my calculation right, 6.179. Okay, work out dy by dx again. So I put in the 1.5, e to the 1.5 plus 2 times 1.5 gives me 7.482. And if I'm going too fast, just slow down, pause the video, and make sure I've got these calculations correct. Finally, I do a half of that 7.482, add on the 6.179, and I get the number 9.92. Now I've already done that calculation, dy by dx, using the initial value when y equals 2, and the real solution is actually 12.38. So I'm getting closer and closer, or 12.39 maybe. I'm getting close to the real solution. To get even closer, my step sizes would have to be smaller and smaller. So I'd have a step size of 0.1 or 0.2. But most likely in the IB exam, you're only going to have to do 2, 3, 4 iterations of this process.